In the last video, I walked you through this chart. In this video, I would like to show you code that showcases the effects visually for the stochastic gradient descent algorithm. I will also show you the effects of changing the number of epochs and changing the learning rate. It will be really interesting. So let's switch to the code. So this is a Jupyter notebook written in Python. It's actually running in the browser in Google Colab. So if you have like a Gmail account, you can go to Google, search for Google Colab. You will sign in and you'll be able to develop your own notebooks. This particular notebook is titled SGD Linear Regression. We are going to use the Stochastic Gradient Descent algorithm to do a simple linear regression for us. So in the notebook, you have what's so-called, if you don't know, text cell and code cell. So this is a text cell. This is a code cell. This is a text cell. This is a code cell. You can see the code cell has a slightly different color from the text cell. The very first thing we're doing here is importing the right packages. The most important package that is relevant to deep learning is the Torch package, which is part of the PyTorch deep learning framework. It's the most popular framework for deep learning. Here we are generating basically some data points, and we will be using stochastic gradient descent algorithm to find the best fit line for the data. These two packages, the PyPlot and NumPy, are not really required for deep learning. I'm just using them here to help us with visualization. So we plot our data. So we have 60 data points basically defined with this line right here. So I'm not going to bore you with what every line means. I would like us to focus on the magic of deep learning and the magic of the stochastic gradient descent algorithm. The first relevant function to deep learning is very simply this one, which really predicts the output for a specific value x. And we're going to be calling this function later when we actually start training the model, finding the best fit line for the data points. The next function, which is relevant to deep learning as well, is to calculate the loss associated with a specific output y hat. So there is a difference between the predicted output and the actual output. And the difference here is really defined as a loss. And this is the function that defines the loss. The next cell basically sets the weight and the bias. Randomly, we chose -50 as the value for the weight, -100 as the value for the bias. And you can actually change these values. And with learning, with training, we will be able to converge very closely to the right values for the weight and the bias. Important to note here is that this parameter requires grad equals true. Basically, we're telling the torch package, but that we would like to optimize the value for the weight and the value for the bias. That's all this means. We're going to set the learning rate to 0.1, and we're going to change the learning rate value to see the effects on the visualization. It'll be interesting. And we're going to store the various losses in this array. And this is the actual training function that we'll call the loss function as well as the predicting function over here. We're going to do multiple passes. So we call them as epochs through all the data points. We're going to predict the output for all the inputs. We're going to add the loss. So we have two different loops here. It's really important to know what's going on here. I'm not going to go into a lot of details, but for each data point, so each data point has an input and output. For each data point, we're going to calculate the loss. We're going to predict the output first, calculate the loss, and then ask the PyTorch package to calculate the derivative or the gradient for us. In this case, it's the stochastic gradient descent algorithm that we are using because we are applying the algorithm on each data point. We get the next value for the weight because we are trying to optimize the value for the weight and the value for the bias. So we get the next value for the weight, the next value for the bias, and then we clear out these values because we're going to loop again and get in fresh values as we converge on the right values for the weight and the bias. So this is the function here again. It's a train function. And we're going to call the function here with 15 epochs, and we're going to change the number of epochs to see the effect on visualization, effect on loss, effect on the values for the weight and the bias. It'll be interesting. And then at the very end, we are going to plot the loss versus the number of epochs, just to see as we do more training, more passes over the data points, we would like to see how the loss changes. So what I'm going to do is run all the code cells. Let's see what happens. Okay, notice the notebook is connecting basically to the Python environment. So it's connected now. It's executing all the code cells. And very soon we're going to look at the visual effects for the stochastic gradient descent algorithm. So it looks like it's done. So let's look at what we got here. So we have a diagram, a, a drawing for each epoch. So this is the initial fit line, and we're trying to find a best fit for the data points here. So the fit line obviously is so far from being a best fit for the data points in this case. This is from epoch number 1. Now, epoch number 2, the data is here, the line is here. It's so far off. It looks like it jumped down. Okay, this is epoch number 4, I believe. Epoch number 5, it looks like it started moving closer to the data points, and you started to see the data points more clearly now because the scale is changing. Okay, it looks like it moved in the opposite direction. However, it's still closer, and you see the data points more clearly compared with this epoch. Wow, look at this. In the next epoch, the line got considerably closer, but it's still not a best fit. Next epoch, look at this. It's getting much closer. Wow. Again. Okay, it looks like this is the best we could do because as we are running more epochs, it doesn't look like there is an improvement in the fit. And that's it. The final weight value from this one is 1.2. The final bias value is -1, -1, 1.0, etc. And the actual value is 1 and -1. So these two values are really, really close to the actual values. Now, if we look at the loss versus the number of epochs, so it looks like the loss is improved rapidly as we go from one epoch to the next at the beginning. But then, starting with epoch 545, you see that the loss is improving very little over time. So we are essentially um, wasting a lot of CPU processing, a lot of memory. Just imagine that this is a very simple model, but in reality, um, very complex models are used for deep learning. So increasing the number of epochs is typically costly from um, a resource usage perspective, like CPU and memory. So you have to keep that in mind. Now, what I would like to do is, as I promised, is change the number. Let's change the number of epochs first. It's very simple. So let's, instead of 15, let's do 5. just 5 epochs, and let's see what happens. Okay, run all. Okay, it's done. So let's start at the top. Again, epoch number 1, epoch number 2, epoch number 3, epoch number 4, epoch number 5. So with 5 epochs, we really didn't get closer. We didn't get a best fit line. So the orange line is way off. And the weight is like minus 0.014. The bias is 2.5. This is not good. And let's look at the loss. So interesting. The final loss, now it's hard to see on this scale, but the final loss is 77, and we want the loss to be close to 0, remember? So so this is not good. As you can see, we did not get a best fit line. Now, let's set it back to 15, I think it was, and let's change the learning rate, which is, let me see, it's set somewhere below here. Okay, so 0.1, let's change it to 0.01. Let's do 0.001. So make it small. So now we're taking small steps. Runtime, run all. Okay, looks like we're done. So let's look at what happened here. Okay, so remember we have 15 epochs and very small learning rate. So epoch number 1, 2, 3. Let me center this. Okay, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Again, if the learner rate is too small, we're not going to get a best fit line. That's very interesting, right? So the final weight is not close to 1. The final bias is even worse. It's minus 17. Now, for the loss, this is the loss function. It's 353. So it's much larger than 0. That's pretty interesting. Now, let's change the learning rate and make it 0.01. Okay, let's run it again. Okay, looks like we're done, I think. Okay. So again, we only changed the learning rate value. We kept the number of epochs the same. So epoch number 1, let's center this. Number 2, number 3, wow, it's getting closer. 4, 5, look at that. 6, oh my goodness, look, this is even better than the first run we did. If you go back and watch the first run, I think this is even better. Oh, look at this. It's so close to the blue line. Okay, now here we don't get any more improvement. It looks like it's not changing much. That's pretty interesting. And then this is very close to 1, and this is very close to -1. And let's look at the loss. The loss is 0.13, which is much closer to 0. This is very interesting. Now, it looks like we found a very good learning rate. And it looks like we are still using a lot of epochs unnecessarily. So let's change the epochs, the number of epochs, make it smaller. Let's try 10. Run this again. Okay, so epoch number 1, epoch number 2, epoch number 3, 4. Okay, the line is moving closer. Wow, look at this. Even closer here. Okay, this is awesome. So with a lower number of epochs, we did really well. So the weight is very close to what it should be. Same thing with the bias. And let's look at the loss. Wow, still, look at this. This is amazing. I mean, we did just 10 epochs, and maybe we don't need 10 epochs. So let's drop it down to save resources. So let's do 7. Run all. Okay, let's see what happened. Okay, epoch 1, 2, 3, 4, 5, 6, 7. We got really close with 7. Same, we got really good weight, close to 1, and this is close to -1. And let's look at the loss. This is amazing. The loss is still small. You can probably do, like based on what we are seeing here, um, we can drop it even further. We can save computer resources, physical resources. We could do 5. I think you get the point. Um, in reality, all these changes can be done automatically in the essentially DevOps pipeline, ML ops, machine learning ops. So this is epoch 1, 2, 3, 4, 5. Not very well. So 5, we went way too far, I think, in reducing the number of epochs. So 5 being the number of epochs is not good enough. So I think 7 is better.